Hello. Hello everyone. Am I audible and visible to you all? Everyone, those who are live. Am I audible and visible to you all? Okay, today we got first we got the set 2. Right? We got the set 2 and we are discussing that part. Okay? So, hello bacho. Sat Sri Akal and Namaste from my side. Right? So, this is your own physics educator Indrajit Singh, welcoming you all into the paper discussion of CBSE 2024 examination. Right, for class 12th, we are going to discuss the set 2 of physics paper. Right? Okay. So, as we are going to start with it, okay, shall we start? Everyone, those who are live, I think very less people are there, but it's okay. We will be having the scroll things right afterwards. Okay. So, see, the first question arises. 3-point charges, each of charge Q, are placed on vertices of the triangle. AB is equivalent to AC and phi L, BC is 6L. The electrostatic potential at the midpoint of the side BC will be what? Right? At the midpoint of the side BC would be what? So here it is like what is going to happen. See, we are trying to discuss these questions. If any issue arises or anything, right, or if any question is missed, do write down into the comment box. The things will be resolved. Right. Now here AB and AC are equal. So it is like AB, AC are equal and BC is the of the length 6L. This is phi L and this is phi L. We need to find the potential exactly at the center here. Okay. The electrostatic potential at the midpoint of the side BC will be what? So this is a BC at the midpoint of the side BC. We need to find the value of the electrostatic potential. Right. So here what happens? First of all, if I am going to tell you all, there are the 3 charges onto the vertices of the equilateral triangle. Okay. So the net potential would be as because of the 3 charges. So we can say it is V1 plus V2 plus V3. Okay. V1 plus V2 plus V3. If I am talking about the charge at B and C would be equal. So it is VA plus VB plus VC. Okay. For see, this is 6, it is exactly divided into the 2 parts. So we can name it as 3L and 3L. If this is 3L, this is phi L. From the Pythagoras theorem, this would be 4L. Okay. Because it is exactly at the midpoint. So the angle would be 90 degree. Okay. So VA, it would be KQ whole divided by the distance is 4L plus KQ whole divided by distance is 3L, KQ whole divided by 3L. So this is going to be KQ whole divided by 4L plus 2KQ whole divided by 3L. Okay. So here the net potential, it is going to be 11KQ whole divided by, right, 12L. Now if I am replacing the value of K, so it is 11Q whole divided by 12 into 4 pi epsilon 0L. So the net potential we are going to have 11Q whole divided by 48 pi epsilon naught L. Okay, this is my perfect answer for this specific question. Understood? Right? This is the perfect answer for this specific question. Okay, so here in this we are going to have A as a perfect answer. Okay, 11Q by 48 pi epsilon naught L. So this was the first question of the set 2. Right? Okay, this was the first question of the set 2. You can just check it out what numbers of the questions we have done correctly. Right? Now let's move on to the second one. Now see the Coulomb force F versus 1 by r square graph for the two pairs. They are talking about what? F is inversely proportional to r square, or you can say it as F versus 1 by r square. We are talking about this graph. So if I am saying F is equal to K Q1 Q2 whole divided by r square, okay, then we must say F is equal to K by r square into product of Q1 Q2. This will be the force for the first pair. Okay, so this is the formula that what we are going to use. Okay, now let's see what it is given. The Coulomb force graph for the two pairs. Here two pairs they have described. The first one is Q1 Q2 and the second one that is a Q2 Q3. The first one that is a Q1 Q2 and the second one that is a Q2 Q3. The charge Q2 is positive and the least magnitude. Okay. Now you can see the graph of the first pair. See, if I am talking about the F versus 1 by r square graph, then from this formula, right, F is directly proportional to 1 by r square. It means this graph would be the straight line graph. The nature of the graph would be straight line. Okay. Now still it depends. F is equal to 1 by r square. Let's say K by r square, it is Q1 Q2. If Q1 and Q2 both are positive, right? If Q1 and Q2 both are positive, right? Then the graph would go onto the first quadrant. The slope we are going to have the positive. Theta will be acute and the slope will be positive, right? So we can say for Q1 Q2 pair, slope will be positive, right? So we can define the graph as F is 1 by r square with the positive slope as theta will be acute angle. But as you can see, this graph of Q2 and Q3 charge is going on into the negative direction. Okay. So for second, it is given as Q2, Q3. So the graph of Q2 and Q3, it is into the negative direction. Now about Q2, it is given as positive. It means that here Q1 and Q2 both are positive. As of that reason, the graph is growing into the first quadrant. Here Q2 is given into the question as a positive, while Q3 has to be negative, then and then the graph will go into the fourth quadrant, right? So here what will be the nature of the charges? Q1 will be positive, Q1 will be positive, Q2 will be positive, but the value would be less than Q1. Why? Because it is mentioned the charge of Q2 is positive and it is of the least magnitude, and while Q3, it is obviously the negative. Okay. So your answer would be Q1 is greater than Q2 is greater than Q3, right? Okay. So this is the second question. Okay. Those who are feeling that अरे यार तुम लोगों को रहना है तो रहो, जाओ, क्यों परेशान कर रहे हो सर, प्लीज फर्स्ट सर स्पैमर्स का बहुत सिर दर्द है सच्ची. magnetic susceptibility of the diamagnetic material. Direct answer, it is always small and negative. Okay, susceptibility for the diamagnetic material. It is 0. Right, for paramagnetic material, the susceptibility is between 0 and 1. On ferromagnetic materials, the susceptibility is greater than 1. So for paramagnetic it is positive, right? And for ferromagnetic materials it is greater than 1. It is positive and it is greater than 1, right? Okay. Understood everyone? The paper will go with my speed only. Those who want to live into the session, they can leave. Those who want to stay, they can stay. I will go with my speed only, right? So please, you don't have to write again and again, ye kar do, wo kar do. Rehna hai row, if you want, you can move. Okay. Next question. A circular loop of a radius r carries the current I. Okay. There is a circular loop whose radius is r and it carries the current I. Another circular loop of B whose radius is r by 20. This is loop of radius A. This is B whose radius is r by 20. Now the question states that the magnetic flux linked with the loop B is proportional to what? Right? Okay. The magnetic flux, see, the current is into the outer loop and they are saying us to calculate the magnetic field for the inner, the flux for the inner. So the flux can be evaluated as magnetic field of the outer loop, the area for inner. So magnetic field for the outer circle, that can be defined as mu 0 I whole divided by 2r. Okay. And here it would be pi r square by 400. So 1 r will get cancelled. The flux is directly proportional to r. And this is a perfect answer for this specific question. Okay. A particle of mass m and charge q is moving with this velocity. If it is subjected to the field, it will move in what direction? Okay, it will move in what direction? Okay, see, let's take an example. Let's take one plane of paper. Okay, now here they are saying that this is an x component of the velocity and this is the y component of the velocity. Okay, while they are saying magnetic field, only realize this is a magnetic field. The lines you can see into the blue, right, it is nothing else but the magnetic field. Okay, now see, the one component that is, right, the one component that is parallel to the magnetic field will remain unaffected. Okay, yes or no? Just hold on, guys. Right, so the path will be helical. See, paper was easy and lengthy. Paper was easy. Okay, paper was easy, but it was lengthy. Say 6th question. The quantum nature of the light explains the observation of the photoelectric effect as. See, the observation of the photoelectric effect. See, there is a minimum frequency of incident radiation below which no electrons are emitted. No. Instead of minimum word, maximum should be there. Okay? Instead of minimum word, maximum should be there. When the metal surface is illuminated, no, electrons are ejected immediately within the time of 10 to the power minus 11 or nearby seconds. Right? Okay? The photoelectric current is independent of the intensity. Yes. Right. The photoelectric current is independent. It depends on the frequency of the radiation. No, sorry, it is dependent. It is dependent. This is also wrong. This is also wrong, and this is also wrong. Maximum kinetic energy, yes. Maximum kinetic energy depends on frequency, but it is independent of the intensity of the light. So, second is the perfect answer. Understood? Everyone, those who are live. Right? The phase difference between the electric field and the magnetic field and electromagnetic waves, you all know about, it is pi by 2. Okay, the phase difference is always. Understood everyone, those who are live? थियरी के भी आंसर बता दूं, चल जाएगा? आंसर तो हर जगह मिल जाएंगे यार. Why you are unnecessary? Why you are commenting into the box? Randomly, why you are commenting? The cross product of electric field and the magnetic field, right? Array 0 is of the oscillation. Acha, हाँ, for the oscillation. Yeah. Sorry. Phase difference between the E cross B is the sign of the electromagnetic wave. The product of E cross V. Should I tell everyone? Should I tell the operator? Should I tell the operator to close this comment box? Tell everyone. Should I tell the operator? Unnecessary if I am getting the comment. Should I tell the operator to close this comment? This is for the Bohr atoms, right? For Bohr atom, that is Ze square whole divided by R square is equal to mv square by R. One R will get cancelled, and mvr, that is equal to nh by 2 pi. Okay, so here you can make the V as a subject, so it is nh by 2 pi mr. Replacing in this equation, you will get the Ze square by R is equal to m n square h square by 2 pi mr square. Okay, so here R is directly proportional to what? What will be the perfect answer for this specific question? So ZE square by R is equal to M. Okay, V is NH by 2 pi MR whole square. So ZE square by R, that is equal to M N square H square whole divided by 4 pi square M square R square. 1 R again will get cancelled. R is directly proportional to N square. This will be your perfect answer. Okay, so this is the derivation of the Ohm's law. Okay, this is the derivation of the Ohm's law. Understood everyone? Right? AC source, the voltage is this. They are telling us to calculate the RMS value of the current. RMS is equal to VRMS by impedance. Impedance will be XC. So IRMS is equal to VRMS. VRMS is 280, 2 whole divided by root 2 into 1 omega C. So it is 282. Okay. Omega is 100. 100 into 10 to the power minus 6 whole divided by root 2. 20 milliampere will be the perfect answer. Understood everyone, those who are live? Okay, so 20 milliampere is the perfect answer for this specific question. Okay, the galvanometer whose resistance is 100, range is given, resistance shunt is given. We can directly use the formula S is equal to Ig dot G by I minus Ig. That is equal to 0.1. So Ig into 100 whole divided by 1 minus Ig is equal to 0.1. Okay, resolving this you will get the answer. Okay, resolving this you will get the answer. Okay, because it's a direct question of the galvanometer converted to a meter. Okay, galvanometer converted to a meter. Set 2 we are discussing. In Balmer series, see, Balmer series of the hydrogen atom, wavelength decreases, and if wavelength decreases, right, the here see what options is given. Spectral line converges. Okay, wavelength decreases as because of that spectral line converges. If the spectral line converges, so the line becomes closer with respect to each other, right, and the intensity is higher. Okay, right, so it is closer and stronger in intensity. The coil of N turns is placed into the magnetic field is perpendicular to the plane of coil. B changes with the time as where T, the magnitude of the EMF is maximum. See, you all know EMF that is equal to N d phi by dt. Can I say EMF that is equal to d? We don't want flux to be maximum. We want EMF to be maximum. We don't want flux to be maximum. We want EMF to be maximum. So here if we are having EMF is to be maximum, then we need d by dt, we need to compare it to 0. So first of all obtain the equation of the EMF, right? Okay, so the equation of magnetic field, so it is Ka dB by dt. So it is Ka d by dt of B naught cos of 2 pi by small t capital T, right? Okay, everyone. Okay, so it will be, so we got the equation of the EMF as differentiating, we get K A B naught sine of 2 pi by T into T, okay, and we will be having omega, or you can say 2 pi, here you can write it as so EMF is directly proportional to sine of 2 pi by capital T into small t, but we don't want flux to be maximum, we want EMF to be maximum, right? Okay, so differentiation of the EMF will be equivalent to 0, so again differentiation of the EMF, it will be cos of 2 pi by capital T. Can you all tell me when the value of the cos is 0? Can you all tell me when the value of the cos is 0? Set number 2 we are solving. Set 2. Okay, we are solving 55 oblique 4 oblique 2. 55, right, oblique 4 oblique 2. Okay. So we'll only have, see, multiples of pi by 2. Pi by 2, right, 3 pi by 2. Okay. Pi by 2, 3 pi by 2. Like this way we will be having 55 oblique 4 oblique 2 we are solving. Right, this was the first set that we received. Okay, this was the first set that was, right, received. And this is the last warning to each and every student. Okay, this is really a last warning. If you are not going to shut this off, right, आगे का पेपर डिस्कस नहीं कराऊंगा, ये कमेंट बंद कर दूंगा मैं. $54. So we are going to compare cos of 2 pi capital T small t. Okay, we get the value of the cos at 0. So indirectly when you are going to compare 2 pi by capital T small t, right, if I am going to compare, if the value of the x, that is 2n plus 1, cos comes 0 for this value, right, cos comes 0 for this value. So 2n plus 1 pi by 2 is equal to 2 pi by capital T into t. From this you will get the answer, right. अभी करते रहो, परेशान कर रहे हो तो करते रहो. We are reaching upon to the assertion, right, we are reaching upon to the assertion and reason. Okay, they are saying, practically they are saying, okay, see, the rest of the options are wrong, but the nearest option is NT by 4. Rest of the options when you are evaluating, now all are wrong, and practically they all are wrong, but here this is the nearest. Within this we are having the two values of the cos, there we are having it, there's a 0. Understood? Interference and diffraction, intensity of the fringes decreases. It only happens into the diffraction, it never happens into the interference, right. Understood everyone? Yeah. Practically, Wrecker, you must say the all, see, all values are not matching, but here both are wrong. When electron drifts in a conductor, it doesn't mean that all free electrons are moving into the same direction. All free electrons never moves into the same direction. Okay, all free electrons never move into the same direction. Okay, only some of the electrons, see, first of all, there is a random motion of the electrons within the part. Okay, so all are not moving. Drift velocity is superimposed, yeah. It is superimposed over the huge number of the electrons, right? So both are correct. Understood everyone? Those who are live can have the answers into the comment box. Assertion and reason were quite simple. Electrons are ejected from the surface of the zinc. See, work function of the zinc, that is equal to 3.74 electron volt. Okay. The wavelength of the yellow light comes 570 nanometer. So if I am finding the energy of the incident light, that is equal to hc by lambda 12400 by 570, right? So what is the value I am getting? 12400 by 570. So it's 25.7 electron volt we are having. See, the energy of the incident radiation is high than the work function. Okay, energy of the incident radiation is high than the work function. Energy of the incident radiation, right, is high than the work function. Energy associated with the photon light is more than the work function of the zinc. Yes, assertion is also correct, reason is also correct, and the reason is a correct explanation of the assertion. Here in this case, A is the perfect answer for the right question. Understood everyone? Temperature coefficient of resistance. See, if I am talking about the conductor, right? Okay, delta R by R, that is equal to alpha delta T. This is the case of conductors. For conductors, resistance value increases with the temperature, while into the case of the semiconductors, it decreases with respect to the temperature. The charge carriers into the metals are negatively charged, whereas the majority charge carriers into the, see, both are correct, but both are not having any relation with respect to each other. Air bubble is trapped. Directly you have to apply the formula of the spherical surfaces, right? This is 1 minus V minus 1.5 by U. U is how much? 20 centimeter is given, is equal to 1 minus 1 by 5 by minus 40. Okay. So it is 1 by V plus 3 by 40 is equal to 1 by 80. Okay, so further when you will resolve 1 by V, that is equal to 1 by 80, okay, minus 3 by 40. So 1 by V, that is we will get 1 minus 6 by 80. Negative of 16 centimeter is the final image form. Understood? Directly you have to apply the formula for the refraction of the spherical surfaces. Understood everyone? Okay. This was the first. If I am talking about the B part, normal adjustment for the refracting telescope, the distance between the objective and eye lens is 1 meter. Into the case of the refracting, the length of the telescope is 1 meter, that is FO plus FE, and the magnification is FO by FE. So magnifying power of the telescope is 19. So FO by FE, that is equal to 19, and FO plus FE is equal to 1. So FO is equal to 19 FE. Replace it here. 20 FE is equal to 1. Focal length of the eyepiece is 21 by 20. Okay. And replacing it to the second equation, you will get the focal length of the objective lens. कह तो रहा हूं पेपर इजी था, पेपर खाली थोड़ा लेंदी था. Understood everyone? So A is also resolved and B is also resolved. What are the matter waves? Okay, it is a very basic explanation. Lambda is equal to h by p. Okay, wavelength, the relation that the waves that shows the relation between the wavelength and momentum are the matter waves. Okay. Proton, electron and alpha particle have same kinetic energy. Write the de Broglie wavelengths associate. Lambda is equal to h by mv. Or you can say, right, they are having the same kinetic energy, right? So direct the de Broglie equation you can apply, where you will get lambda of alpha is less than lambda of proton is less than electron. This is a perfect answer. Yeah. They are all having the same kinetic energy, na? So lambda is inversely proportional to under root of m. Understood everyone, those who are live? Let's move on to the 19th question. The ray of the light is incident normally on the one face of the equilateral glass prism. Okay, now when the prism is completely immersed into the transparent medium, it is observed that emergent ray just grazes. See, this is an equilateral prism. Outside we are having the transparent medium. The ray goes normally like this way. So it gets incidents at some angle and it grazes. Grazes, it means it is going out at 90 degree. This is the emergent ray. Okay, this is emergent ray. Okay, so directly I am applying the Snell's law, refractive index of the prism. Okay, sine of I, that is equivalent to the refractive index of the air, or you can say transparent medium, and that is sine of 90. Now here what? If this is 9, see, if this is 90, this is also 90, right? If this is equilateral, this is 30. So this will be 60. So here it is, refractive index of the prism is sine of 60 is equal to 1. From this you will get the refractive index of the 2 by root 3 is a perfect answer for this specific question. Understood? 19th question. Two wires A and B have their lengths ratio, okay, 1:2. Suppose first of all, I by V graph, that is equal to 1 by R, is equal to slope of I versus V graph. Okay. So 1 by RA, that is equal to 10 of 30. Okay. 1 by RB, that is equal to 10 by 45. 1 of RA, that is equal to 10. Right. So from this you will get the, this is 1 by root 3 and this is 1. So RB by RA, that is equal to 1 by root 3. Now R is rho L by A. Okay. So rho 2 L2 A2 rho 1 L1 into A1, that is equal to 1 by root 3. So you can replace the length ratios and the radii. See, length and the radii ratios are given. Okay. So here you will get rho 2 by rho 1 into L2 by L1 into R1 square by R2 square is equal to 1 by root 3. From this you will get the ratios of rho 1 and rho 2. Okay. Understood everyone, those who are live? Draw the circuit diagram of the PN junction diode into the forward bias and the reverse bias. Okay, this is a very common question. Okay, into the forward bias, the depletion barrier is less. Okay, the width of the depletion barrier is less. I am drawing for the forward bias, right? So here we will be having the electrons and here we will be having the holes. Right. So the width of the depletion barrier is less. This is rheostat attached to it. This is the negative terminal. This is the forward biasing of the PN junction diode. Forward biasing of the PN junction diode. Right. The width of the depletion barrier is less. Okay. And if I am talking about the reverse bias, the width of the depletion barrier is huge. Here we are having holes, here we are having electrons. Sorry. Right. Paper easy tha, paper is easy, paper was easy, but it's lengthy. Paper was easy, but it was lengthy. Right. Right. So here this is the reverse bias. Okay. This is the reverse biasing. The positive is connected to the negative terminal. This is reverse biasing. Okay. The graph of the number of the scattered particles and the scattering angle. See, this is the number of the scattering particles and the graph is like this way. right? You know about the expression of the closest approach, right? Circuit diagram, Chandan beta, you have to draw the circuit in detail, right? And it's like you have to explain the each and every step into the VI characteristics, because it was 3-mark question. Okay, it was a 3-mark question. Okay. Understood everyone? Those who are live, can have the answers into the comment box. Okay, there is a thin spherical shell of radius r and a charge q. See, there is a shell of charge q and radius capital R. At the center of the shell, the small q, find the charge density on the outer surface. See, charge density on the, if the charge q is present in the center, as because of the electrostatic shielding, all electric field lines will get dead at the, all electric field lines are going to be dead at the surface. Okay, all electric field lines are going to be, or a derivation is necessary, because we are not dealing, see guys, if you are having that kind of a psychology that you are, okay, the JEE or NEET student and the board is not having any kind of a relation with it. If they are saying, if they are interested in derivation, you have to write it down. The charge density on the outer shell. Okay. See, potential at the distance r by 2, it is going to be common, kq whole divided by, right? Okay. Because this is the potential inside the shell is constant. Okay. Potential inside the shell, right? Okay. And through which you can calculate the density of the outer sigma, that is equal to small q into pi capital R square. Okay, for the outer surface. Differentiate between nuclear fusion and fusion. This was a very simple, you can do it, right? In one fission, you all know the difference between the fusion and fission, right? In fission, disintegration process is going on. In fusion, two atoms combine to form the new one. In fission, one disintegrates into the child. Understood everyone? In whatsoever paper, if it is 2 mark, see, different sets, it means that understood everyone, those who are live? The fission properties of Pu are very similar to how much energy in mega C. The average energy released, that is 180 megavolt electron volt. Average energy released, that is 1, right? In 1 gram, there are approximately 2.51 into 10 to the power 21 number of the atoms, right? So the total binding and total energy, you can say it as 2.51 into 10 to the power 21 into 180 mega electron volt. You will get your answers. Okay. Understood everyone? Two long insulated wires carries the current of 3 and 5 ampere. Okay. See, one infinite wire is along x-axis. Find the magnitude and the direction of the net magnetic field at the point P1. Perpendicular distance is 2. We are only interested in perpendicular distance, right? And this is also 2. Okay. As because of the 1, it will be dot cross, and as because of 2, it will be cross. Okay. So at the net magnetic field at the point P1, that is magnetic field as because of 1 plus magnetic field as because of 2. So mu 0 I whole divided by 4 pi perpendicular distance into sine of 90 plus sine of 90 cross. Mu 0 I whole divided by 4 pi d2 sine of 90 plus sine of 90 cross. Okay. Both are having the cross. Both are having the cross. Good afternoon. Right. So this will be mu 0 I whole divided by 2 pi perpendicular distance is 2 cross plus mu 0 I whole divided by 4 pi perpendicular distance is 2 cross. One is having the current of 5 ampere, one is having the current of 3 ampere. So that is mu 0 5 plus 3 whole divided by 4 pi cross. This is a net magnetic field at point P1. This is application of the Biot-Savart's law. One of the application of the Biot-Savart's law. Right. Now we are moving forward to the second point. -1, 1. -1, 1. So the perpendicular distance is going to be, as because of the one wire, this will be dot, as because of the two wire, it will be cross. At this point, it will be 0. Because one is in dot, sorry, not will be 0, let's evaluate. The values of the currents are different. So BP2, that is equal to mu 0 into 3, 2 pi. Okay, it is 1 dot plus mu 0 pi 2 pi 1, and that is cross. Okay, so you can replace, you can solve and get the answers, right? Sir, 0.10, no, because the values of the current are different. If we are having the same value of the current, then at point P2 it would be 0. The values of the current are different in both of the cases. Values of the current are different in both of the cases, Ankur. What is mean by the displacement current? How it is current? Okay. Maxwell did one experiment. Okay. He took one he took one capacitor. Right. He said that Ampere and circuital law violate. Suppose if I am going to take two loops, this is Ampere and loop A1 and A2. According to the definition of the Ampere circuital law, right? Integration of just hold on, guys. Integration of B dot dl, integration of that is mu 0 Ni. According to the Ampere circuital law, this equation should be valid for all Amperean loops. But Maxwell said that if I am taking an Amperean loop in between the two plates of the capacitor, right, this is applicable for Amperean loop 1. But if I am taking BDL for the Amperean loop, this becomes 0. So here the law violates. Here the law violates. Okay. Here the law violates. So as of that reason, the Maxwell said that in between we are having one missing term. He said that if the electric field is getting changed, as because of the change in electric field, one magnetic field is produced that gives rise to the one current which is known as displacement current, right? So here the missing term was integration of B dot dl, okay, that was plus magnetic flux, right? So here the missing term into the Ampere circuital law defines the displacement current. Understood, everyone, those who are live? Okay, the missing terms into the Ampere circuital law defines the displacement current. Okay, so this description you have to write it on, and the explanation of the entire capacitor they demands. Okay, you have to give the entire explanation and you have to justify your answer, because this is a 3-mark question. Okay. Find the currents flowing through the branches AB and BC. Okay. Suppose I am taking this as a reference plus minus, right? Let us take an example. This is a I current flowing through the circuit, from which it gets divided into two parts, I1, I2. Okay. Now if I am applying, see here if it is 10, here it is plus 10 volt. So if I am applying the Ampere KVL, first I will apply the KVL for loop MB ANM. So I will be getting minus 10 of I, minus 5 of I1, plus of phi is equal to 0. So phi is equal to 10I plus phi of I1. Instead of I can write I1 plus I2 plus I1. So 1, that is equal to 3I1 plus I2. This is the first equation that we got. This is the first equation that we got. Now I am going to apply the Kirchhoff voltage law for M, B, C, D, M. Minus 10I minus 5I2 minus 20I2 plus 10 is equal to 0. So you are going to have 10 is equal to 10I minus 20 plus 25I2. So 2 is equal to 2I plus 5I2, replacing the value of I. 2 is equal to 7I2 plus 2I1. This is the second equation. Solving 1 and 2, you will get the specific answer for the values of I1 and I2. Right? Yeah, you are having, if you are having your concepts clear, then and then you can solve. If you are having your concepts clear, then and then you can solve. If your concepts are not clear, you can't solve the paper. Define mutual inductance, writes as SI unit, not a big deal. Take two coils. As because of the current flowing into the coil number 1, right? Okay. This produces the magnetic field. As this magnetic field changes, right, this induces the current into the second loop. So the mutual inductance is defined as M12, flux S because of 1, current into 2, so the mutual inductance, that is equal to flux whole divided by I. Change in flux, mutual inductance in 2S because of 1, change in flux S because of 2, current is S because of the 1. Okay, unit is Henry only. Okay, see, for the two coils you have to derive the expression, right? So you can derive the expression, one is having the higher radius, one is having the lower radius. बहुत ही ज़्यादा spamming हो रही है यार. I don't know why you all are wasting your time. Ferromagnetic materials. Explain the ferromagnetism with the help of the suitable diagram. Use the concept of magnetic domain. Okay. See, ferromagnetic materials. In absence of magnetic field, when magnetic field is switched on, when magnetic field is switched on, whether it is set 1, set 2, जो भी हो, questions are is one and the same only यार. थोड़ा change इधर उधर किया हुआ है क्या यार इतना. Suppose magnetic field is switched on. Okay. Then all the dipoles will try to arrange themselves into the direction of the external magnetic field. All the dipoles tries to arrange themselves into the direction of the external magnetic field. Like this way. The position, see, whatever the arrows you are seeing here, okay, whatever the arrows you are seeing here, whatever the arrows you are seeing here, even into the absence of this remains same. In absence of external magnetic field. As of this reason, it is said that susceptibility of the ferromagnetic materials is high. Susceptibility of the ferromagnetic material is high. It is greater than 1. Okay, and the artificial magnetism can retain for the long amount of the time into the ferromagnetic materials. Artificial magnetism can retain for the long time into the ferromagnetic materials. Okay, so what are the ferromagnetic materials? Explain the ferromagnetism. Okay, so the property of the ferromagnetism states that, okay, the dipoles into the specimen are aligned even into the direction of the magnetic field into the absence, right? Even the magnetic field is switched off, the magnetism, the artificial magnetism retains for the long amount of the time. So either you have to apply for this or this, both were 3 mark question. Now we are directly going on to the case study based question. Okay. The long description is given: transparent optical medium, two surfaces. But directly if we are going to see, converging lengths of focal length 20 centimeter and diverging lengths of focal length 15 centimeter. 1 by f, converging lens is having the positive focal length 1 by 15 minus 1 by 20. Okay, converging lenses is having 20. So that is 1 by 20 minus 1 by 15. Okay. So the resultant focal length, that would be 15 minus 20 by 20 into 15. Okay. So 5 3s are. So 1 by f, that is equal to negative of 1 by 60, 10 to the power 2. So, okay. So focal length, that is equal to negative of 60 into 10 to the power. If you want to find the power of the lens, then power is an inverse of the focal length. So power is 1 by focal length, that is negative of 10 to the power 2 by 60. 1 will get cancelled, 10 by 6. Right. So negative of pi by 3 is the perfect answer. Negative of pi by 3 is the perfect. Yeah, B is the perfect answer. The resultant focal length. The radius of the curvature of the two surfaces of the convex lens are R and 2R. Okay, if the focal length of the, okay, see directly we can apply the focal length 1 by f, that is equal to eta 2 by eta 1 minus 1 into 1 by r plus 1 by 2r. Okay. So this will be 4 by 3r is equal to eta minus 1, okay, 3 by 2r. Focal length is 4 by 3r, so it is 3 by 4r. So r will get cancelled, 2 2s are, 3 will get cancelled, n minus 1 is equal to half. 3 by 2, 3 by 2 is the refractive index of the material. N minus 1 is equal to half. Right. Now they are telling about the focal length of the equiconvex lens. Focal length of the equiconvex lens is eta minus 1 2 by r. From this formula we will get the answer. This was a very nice question. First you have to apply the mirror, the lens formula, and you have to apply the mirror formula, right? Focal length of this 1 by v minus 1 by u is equal to 1 by f. Okay. Focal length is 10. So the final image will be at 10 centimeter. Okay. From here, the first image is formed at 10 centimeter. Now this is 40. So this virtual image will act like an object for the another. So 1 by v plus 1 by u is equal to 1 by f. So 1 by v, that is equal to 1 by f. Focal length of the concave mirror is what? 15 centimeter. So it is 1 by 15 minus 1 by 30. Okay. So the 1 by v, that is equal to, this will be also negative 1 by 15 plus 1 by 30. So 1 by v, that is equal to what? Negative of 30 plus 15 whole divided by 15 into 30. So v is equal to 15 into 30 whole divided by negative of 15. Negative of 30 centimeter in front of the mirror. Okay. because it is a twice the focal length of the convex mirror. So it will be on the center of curvature only. Okay. 20 centimeter onto the 10 centimeter onto the right of the lens and 30 centimeter to the left of the mirror. Okay. A beam of light coming parallel to the principal axis of the convex lens, 1 by V minus 1 by U is equal to 1 by F. First image is formed at plus 16 centimeter from convex lens. Okay, there is convex lens of the focal length. Okay, another convex lens is kept at the 40 centimeter. Okay, this focal length is of 16 centimeter, this is of the 12 centimeter. So again, if you are going to apply the formula 1 by final, that is negative 1 by, here if it is 16 centimeter and 40 minus 16, here it will be 24. So negative of 24, that is 1 by positive of 12. Okay. So the final it would be 1 by 12 plus 1 by 24, 3 by 24. Okay, from this you will get the perfect answer. Okay, 2 times you have to apply the lens formula. Understood everyone, those who are live? Understood everyone, those who are live? Can have the answers into the comment box, please? Right. Shall we move forward to the next question? LCR series circuit resonant factors, right? Plot the graph. Okay, you have to plot the graph of impedance. This is the resonance point. Impedance versus frequency. Left side it is purely inductive. With the help of the, okay, this is A part. Okay, value of the resonant frequency completely depends on to the value of the inductance, right, capacitance and resistance, right? Understood everyone? Inductance and capacitance. Understood everyone, those who are live? Step up transformer. Okay, step up. Primary coil, secondary coil. Number of the turns into the secondary coil, number of the turns into the primary coil. Okay, voltage supplied to the primary coil, voltage supplied to the secondary coil. Okay, this is a step up transformer. Okay, input power, that is equal to output power for the ideal transformer. Okay. So here we can say V primary, right, current primary, secondary, current secondary. So Vp by Vs, that is equal to Is by Ip. Similarly, that is equal to Np by Ns. Understood? Okay. Case study questions are done. Now you are suddenly coming up telling us solve the case study question. See to the previous part of the session. It's 1 hour and 15 minutes to the lecture. The case study questions are done. Okay, so this is a 5-mark question. This is a direct theoretical based question. The construction of the AC generator. I am coming, just 1 minute. Okay. Electron is revolving around a proton of radius r. Obtain the expression of the magnetic moment. Expression of the magnetic moment. Magnetic moment is I into A. Area is pi r square. I is q by T into pi r square. T is a time period for revolution. 1 hour will get cancelled, 1 pi will get cancelled. N E V R by 2. Electron is 1. So the magnetic moment is E V R by 2. This is the expression of the magnetic moment for the moving electron, okay, around the nuclei. Let me check. Wait. 1 hour saying 30, okay. Question number 30. Semiconductor it is, okay. Question of semiconductor, question number 30, one case study. Wait. See, 30 number case study. Ionization energy for pentavalent. What it is? Germanium is doped with the pentavalent impurity, right? Ionization energy is second option, 0.01 electron volt if you want to remove 1 electron from its ground state. This is the ionization energy, right? So answer for first is 0.01 electron volt. For second, right, it is Ni square is equal to number of electron into the number of hole, right? The density of the intrinsic semiconductor is given 2 into 10 to the power 10 whole square. Number density of the electrons we need to calculate, and this is 8 into 10 to the power 3. From this you will get the answer. This is a direct formula that shows the relation of the number densities of the intrinsic semiconductors with the electrons and holes. The third question is diffusion of the PN junction. During the formation of the PN junction, electrons from N side diffuses and holes from P side to N. And the last, diffusion current is always greater than drift. Right? Electrons go from N to P, right? And holes go from P to N. Now it is resolved. Case study 30 is resolved with everyone, those who are live. Thirty is resolved. Fourth part, that is what I said, na, diffusion current is greater than drift current. Okay, this is the derivation of the parallel plate capacitor. See, this is a parallel plate capacitor. One slab is introduced of thickness T, and this is D, right? So the net potential, that is potential as because of the space plus potential as because of the slab, right? Potential as because of the electric field E naught into D minus T plus electric field E. For the slab it is T. So this is E naught D minus T plus E naught by K into T. So that is E naught D minus T plus T by K. We got the potential. From the formula Q is equal to CV, right? Q is equal to capacitance E naught D minus T plus T by K. E naught we can replace as sigma by 2 epsilon 0, or a sigma by epsilon 0 D minus T plus T by K. From this you will get C is equal to epsilon naught A by D minus T plus T by K. This is the derivation of the capacitors. Understood everyone, those who are live, the derivation of the capacitors. Right? श्रुति बेटा क्वेश्चन 30 का पार्ट 4 मैंने बोला ना, they are saying which current is higher, diffusion current or the drift current. So diffusion current is always greater than the drift current. Let me check. Okay, हाँ, half wave rectifier ना. Okay, 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 okay. For half wave rectifier, frequency is going to be 50 hertz. For full wave rectifier, the frequency becomes double, 100 hertz. Right? Half wave and full wave rectifier is there, right now? 30 question number. Am I correct? Right, beta? हाँ, फ्रीक्वेंसी बोल रहा हूं, क्यों चिल्ला रहे हो इतना? Using the Gauss law, okay, see, this is the infinite sheet. We are using the cylinder as the Gaussian surface. Okay, integration of E dot dA, that is equal to Q by epsilon naught. Okay. Solving this, you will get sigma by 2 epsilon naught. Okay, this is an infinite plane sheet and we are having the cylindrical Gaussian surface. Okay. And here the flux, we can say flux is equal to E dot A. Now here saying we need to calculate the flux through the cube. The net flux through the whole cube is 0 because the number of the electric field lines entering and leaving the system are same. Paper was not hard, paper was lengthy. The number of the electric field lines entering and leaving are same. Okay. No. They are not same. Wait. Okay, wait. Okay, wait. It is not like that. It is integration of E dot dA. Okay, no, wait, it is not like that. Here the electric field is variable with respect to time. If electric field is constant, then and then number of the electric field lines entering and leaving is same, right? Okay. So here it will be integration of, okay, phi x square plus 2 into, suppose we are having the strip dx. For dy x will be 0. So on integrating this, you will get the value of the flux. The limits of the integration would be 0 to 10. Okay. Fail. Draw the ray diagram. See, directly the ray diagram for the convex mirrors they are asked. It is very easy. Directly you can see all the images that are formed by the convex mirrors are virtual and erect. At whatsoever the position you are going to keep the object, the images will be always formed between the focus and pole. In case of convex mirrors, whatsoever the location of the object should be, images will be always formed between the focus and pole. Why the multi-component of the, to decrease the optical defects. Answer for the second is to increase the image quality and decrease the optical defects. Understood? The magnification of the small compound microscope, directly you can apply the formula. The magnification is given 25 by the focal length of the eyepiece is given. From this you will get the magnification produced by the objective lens, right? Magnification produced by the objective lens. In another sense, you can say M is equal to, right, D by Fe. Okay, 400 whole divided by 2.5 something into the centimeters. You can replace centimeters into all, right? Differentiate between the wavefront and the ray. When the bunch of rays, wavefront is an imaginary surface, right? You all know about the wavefront. Okay, you all know about the wavefront. भाई कौन सा 32 भी रह गया? करवाया तो सही, ये तो रहा, और क्या है, ये तो रहा, बस अननेसेसरी बोले जा रहे हो यार. It's a direct Gauss law, direct derivation of the Gauss law. This is a direct derivation of the Huygens principle. This is directly given into the book. इसमें क्या है यार? differentiate between the wavefront and a ray. Ray is actually, you can say it is a path, the straight line on which actually light travels. Or ray you can consider, okay, the bunch of the rays. Let's differentiate clearly. Imaginary surface formed by the set of points imaginary surfaces formed by the set of the points that oscillates with the common phase. See, these are the set of the points that are oscillating with the common phase, right? It forms the imaginary surface, right, which is known as wavefront. There are some examples of the wavefront. If we are having the paraxial rays, we are having the plane wavefronts. From the point source of light, right, okay, we are having the spherical wavefronts. From the line source of light, we will be having the cylindrical wavefronts, right? This is the explanation of the wavefront, yes or no? And what is ray? The line of a light. It is known as the ray. Okay. बेटा कैपेसिटर वाला डायरेक्ट डेरिवेशन है, क्या हो गया है यार? ये वाला अच्छा चलो. Two capacitors of the different capacitors are first in series and then in parallel. Okay. चलो यही देख लेते हैं. B part. Two capacitors of the C1, C2. First they are connected in series, right, across the 100 volt. Then they are connected in parallel, okay, across the 100 volt. The total energy, see here, total energy stored in this combination, right, that is equal to half C1 C2 by C1 plus C2 V square. Okay, wait. This is a very nice question. $40 and 250. Okay, see, 40 millijoule is equal to half C1 C2 whole divided by C1 plus C2 whole square into volt. Sorry. And 250 millijoule is equal to half C1 plus C2 into V square. Find the capacitance of the half, 40 and 250 millijoule. Okay. Now suppose if you are going to take the ratio, half is going to get cancelled. The formula that we have used, half C equivalent into the V equivalent square. Or you can say V supply. So 40 by 250, that is equal to C1 C2 whole divided by C1 plus C2, right, whole square. Understood? अंडरस्टूड बेटा, यस और नो? किसने बोला था यार? प्रथमेश प्रभु फिल्म्स. right? Even you can compare Did you all understood? Everyone, those who are live can have the answers into the comment box. Everyone, the OR question we have solved. OR question comes the Gauss law, and that we have resolved, right? Paper ends. A part of the question has already been resolved. The derivation of the capacitor is already done. Let's keep that much enough for today. Bye everyone. Stay at home, stay safe, stay healthy amidst this pandemic, and take care.